Hi, Mr. Richards here. Today's grade 6 practice problems review on Unit 5, Lesson 3 is adding and subtracting decimals with few non-zero digits. In question 1, here is a base 10 diagram that represents 1 and 13 hundredths. Use the diagram to find 1 and 13 hundredths minus 46 hundredths. Explain how you found the difference or label your diagram to show your steps. Well, if we write this out as we would traditionally write this out, we'll notice that we can't take away 6 hundredths from 3 hundredths. So what we need to do first is to unbundle this tenths into hundredths. And there are 10 hundredths in 1/10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so this one has gone away. And essentially what we've done then is we've unbundled that 1/10. We have 0 tenths left. And now how many hundredths do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hundredths. And so that's where those 13 hundredths come from. Now we can subtract, we can take away 6 hundredths from this. So 1, 2, 3, 4, 5, 6. And what are we left with now but 1, 2, 3, 4, 5, 6, 7 hundredths? And sure enough, 13 hundredths minus 6 hundredths is 7 hundredths. And now as we look to our tenths spot, we can't take away 4 from nothing, can we? And so now we need to take a look at our ones, and we're going to unbundle our ones into tenths, and there are 10 tenths in ones, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've essentially unbundled our one whole into 10 tenths. Then I can take away 4 of these now. So 1, 2, 3, 4. And what are we left with but 1, 2, 3, 4, 5, 6 tenths? And sure enough, 10 minus 4 is 6. Our decimal point, we have no ones left, and so we have a solution here of 67 hundredths, which, if you break that down, again, is 6 tenths, 1, 2, 3, 4, 5, 6 tenths, and 7 hundredths. 1, 2, 3, 4, 5, 6, 7. It's nice to see the visual of how subtraction with decimals work. You may have heard the term borrowing before, and that's essentially what we're doing when we're unbundling. Compute the following sums. If you get stuck, you can draw a base 10 diagram. Let's go ahead and neatly line these up here in A. 0, decimal point, 0, 2, 7, and then 0 with our decimal point, 0, 0, 4. So A neatly lines up for us here. We can add the 7 and the 4, which are in the thousands place, and we end up with 11 thousandths. So basically, move 1 hundredth over. We have 1 plus 2 plus 0 is 3 in our hundredths. We have no tenths, and we have no ones, and so our solution here is 31 thousandths. Now as we move on to our next question, in B, 0.203 3, so 203 thousandths, plus 0 decimal point needs to absolutely line up here. You have 2 in the tenths, we have 1 in the tenths there, so our 1 in the tenths lines up with our 2 in the tenths. And now let's put in some of these zeros there to make sure everything nicely lines up. And then add, starting with the right, going left. 3 plus 0 is 3 in our thousandth spot. 0 plus 0 is 0 in our hundredth spot. And 2 plus 1 in our tenth spot results in 3 in our tenth spot. Decimal point comes down. And our 0 in our 1 spot. So we have 303 thousandths as our solution. And our last question over here, C, we have 1 and 2 tenths added to nothing in the ones, but then we have 1 in our tenths, 4 in our hundredths, 5 in our thousandths. And so if we put in these zeros in our hundredths and thousandths spot, we can now have it neatly set up so we can add. 0 and 5 in our thousandth spots results in 5 thousandths here. 0 and 4 in our hundredths is 4 hundredths. 2 and 1 in our tenths is 3 tenths. Decimal point comes down. And 1 in our ones plus 0 in our ones is 1. And so we have 1 and 345 thousandths. In question 3, a student said we cannot subtract 1 and 97 hundredths from 20 because 1 and 97 hundredths has 2 decimal digits and 20 has none. Do you agree with this statement? Explain or show your reasoning. And I am going to disagree. You can really technically subtract any number from any number, but we'll get there eventually. If we start off with 20, it's 20 with the decimal point here. And we're going to take away, subtract 1 and 97 hundredths from this. 9 in our tenths and 7 in our hundredths. Our 20 has 0 in our tenths and 0 in our hundredths. So we can subtract this. Now, we do need to unbundle. We have 2 in our 10 spot. So if we take a 10 away and bring it over to our ones, this results in 10 ones. And we need to unbundle one of the ones to result in 9 ones left to come over and have 10 tenths from that 1. Then we need to unbundle one of those tenths to result in 9 tenths, which gives us 10 hundredths. And now we can subtract. 10 hundredths minus 7 hundredths is 3 hundredths. 9 tenths minus 9 tenths is no tenths. 9 ones minus 1 1 is 8 ones. And 1 10 minus, well, 0 tens is 1 10. So our result here is 18 and 3 hundredths. Question 4. Decide which calculation shows the correct way to find 3 tenths minus 6 tenths, hundredths, thousandths, and explain your reasoning. Let's examine these. Good learning opportunity here. In A, we have our decimal points lined up correctly, but we didn't put in the 0 in the hundredths and the thousandths, and we just ended up bringing the 0 and the 6 down, and that's not correct because there's nothing to take away from up here. That you need to take something away, so unfortunately A is not correct. B is not correct as we did not line up the decimal points. We were taking away thousandths from tenths here, and that's not going to work. Same thing with C. decimal points are not lined up. We threw a 0 in here, which was a step in the right direction, kind of like a head fake. But here we have our hundredths spot lined up from our thousandths spot, and you can't take thousands from hundreds, so sorry, C. And then we look at D. Decimal points are lined up. We have our zeros representing our no hundredths and no thousandths. And it does look like we unbundled here just a little bit as we took a tenth and moved it over to our hundredths and borrowed or unbundled from our hundredths and made that 10 thousandths. And then they subtracted here. 10 minus 6 is 4, 9 minus 0 is 9, 2 minus 0 is 2. So it looks like we have a correct solution here in D. Question 5. Complete the calculations so that each shows the correct difference. A is a nice one to get us going here. They already took 6 tenths minus 4 tenths to get 2 tenths. 2 ones minus 1 1 is 1 1. And, you have zeros here technically. 4 minus 0 is 4, 1 minus 0 is 1, so you get 141 and 2 tenths. B, well, they didn't show something yet that I want to make sure that we show, okay? They didn't just copy down this 5. It's not just copied down. What they needed to do was unbundle the 6 tenths, take a tenth away to make it 5 tenths, and make that tenth into 10 hundredths. And so what they started with here was 10 hundredths minus 5 hundredths to get 5 hundredths. Now, you cannot take 7 tenths away from 5 tenths in this question, and so we need to go over to our ones, unbundle the 8, so we're down to 7 ones, add 10 tenths to this 5 tenths that's already there, and now you're at 15 tenths. 15 tenths minus 7 tenths will get us 8 tenths. And now I should be able to just take our 7 ones minus 6 ones, and that's 1 ones. And then 3 tens minus 0 tens is 3 tens. So we get 31 and 85 hundredths. Now something similar is taking place here in C. Again, we have this 8 here, and where in the world did that come from? Well, we unbundled the 7 and unbundled one of the 10s to turn this into a 6. Added 10 hundredths to the 6 hundredths that were there, and that became 16 hundredths, and then 16 hundredths minus 8 hundredths was this 8 hundredths here. Now we can take away 1 from 6, so 6 tenths minus 1 tenth is 5 tenths. Now we can't take 2 ones away from 1 1, so we need to unbundle the 4 tens into 3 tens. And that's going to add 10 there, but oops, there's a mistake. This is going to be 10 added to that to make it 11. And so 11 minus 2 is 9. And the rest of these are zeros in the tens and hundreds, so 3 tens minus 0 tens is 3. 2 hundreds minus 0 hundreds is 2. So we have a final result of 239 and 58 hundredths. In question 6, the school store sells pencils for 30 cents each, hats for $14.50 each, and binders for $3.20 each. Elena would like to buy 3 pencils, a hat, and 2 binders. She estimated that the cost would be less than $20. Do you agree with her estimate? Explain your reasoning. Well, if we look at what she has so far, she has a hat at around $14.50. 2 binders are going to cost about $6.40, or exactly $6.40. So just looking at this alone, you're already at $20.90. And so that doesn't even include the pencils yet, so we're going to say no, disagree. I mean, you haven't even added the pencils in yet. Now estimate the number of pencils you could buy for $5. And we're estimating here, and so if each pencil is 30 cents, you could get about 3 pencils for every $1. And if she has $5, you could multiply by 5 to get 15. You could also say about 16 as well, knowing that you're not quite at $1, so you can kind of round up here a little bit too. But either 15 or 16. Question 7. A rectangular prism measures 7.5 centimeters by 12 centimeters by 15.5 centimeters. Calculate the number of cubes with edge length ½ centimeter that fit in this prism. Well, if we take our one side here at 7.5 and divide by 1/2, we can find how many cubes that are ½ centimeter will fit on that side. And so this leaves us with 15 halves divided by 1/2. And if we keep, change, flip, in order to multiply, we can cross simplify these to 1, and we get a solution of 15 cubes on that side. And we'll just keep kind of doing this. We have 12 divided by 1/2, and so 12 over 1 divided by 1/2. Keep it, change it, flip it. You end up with 24 cubes along this side. And then lastly, well, not last, but last side, we have the 15.5 side divided into ½ centimeter cubes, excuse me. That's 31 halves divided by 1/2. And if we keep, change, flip, cross simplify by dividing by 2, you get 31 cubes. And so now that we know how many cubes fit along the sides, we have the side that has 15 cubes, the side that has 24 cubes, and the side that has 31 cubes. We can multiply this together and get 11,160 cubes. What is the volume of the prism in cubic centimeters? Show your reasoning. If you get stuck, think about how many cubes with ½ centimeter edge lengths fit into 1 cubic centimeter. A couple different ways of going about this, all right? The first way is just to kind of gut it out, knowing that volume equals length times width times height. And what I mean by that is to literally take the 7.5 times the 12 times the 15.5. And so improper fractions would be 15 halves times 12 times 31 over 2. And there is some cross-simplifying we can do here. We can divide by 2 there and there to get 1 and 6. And you can also then divide by 2 here and here to get 3 and 1. And then you could take 15 times 3 times the 31 and get 1,395 cubic centimeters. I mean, that's one way of solving it. The other way is knowing that we have 11,160 cubes. What is the volume of each one of those ½ centimeter cubes? Well, 1/2 times 1/2 times 1/2 is 1/8 cubic centimeter. And if you happen to have 11,000 of those, about 11,160, you can multiply by 1/8 here, and you will still get 1,395 cubic centimeters. So a couple different ways of getting there in our 7th question. Now on to question 8. And in question 8, at a constant speed, a car travels 75 miles in 60 minutes. How far does the car travel in 18 minutes? If you get stuck, consider using the table. Well, it's beautifully set up for us here. How do we get from 60 to 6? Well, we can multiply by 1/10 or just divide by 10, same thing, which gets us 7.5 miles. Then our next step here, 6 to 18, multiply by 3. And so we finish this side by multiplying by 3. 7.5 times 3 is 22.5 miles. So that is it for this lesson, Grade 6 Practice Problems Review on Unit 5, Lesson 3, Adding and Subtracting Decimals with Few Non-Zero Digits. Good luck.